It's a happy to be back at the Databricks Data and AI Summit. I am Sudipta Das from PepsiCo, and today we are excited to share the next chapter in our journey of powering secure and scalable data governance platform using Unity Catalog Open API. If you were here last year, thanks for joining us again. Our today's session is the continuation of our work that we have done in the last couple of years. Our focus will be mainly on how we have matured our architecture and unlock new capabilities using Unity Catalog Open APIs. I am joined by Dipankar Kushari from Databricks.
Hi everyone.
He will cover the details of the UC Open API shortly. He has been a great collaborator and a key contributor towards the evaluation of our design. A quick introduction of myself and Dipankar. I have over 2 decades of experience managing large-scale enterprise application. For the last couple of years, I am managing Enterprise Data Foundation platform at PepsiCo, which includes the entire platform, the automation, framework, services, governance, and policy. Dipankar?
Hey everyone. I'm a lead specialist solutions architect with Databricks. Been with Databricks more than 3 years now. I specialize in data governance and Unity Catalog.
Thank you. So, I believe PepsiCo does not need any introduction. It's a well-known brand globally, but as a quick reminder, PepsiCo is a global food and beverage leader, operates in over more than 200 countries. In 2024, our net revenue was more than $92 billion and core operating profit was about $15 billion. And in all this, data is the heart of how we drive performance, efficiency, and innovation across our product portfolios. Now, what is Enterprise Data Foundation, or EDF as we call it in PepsiCo? It's a unified, governed data platform that enables seamless data access and insights across PepsiCo. We built it to be a one-stop shop for all the data and analytics needs that supports more than 100 executive leaders across all the sectors globally. In our production system, we houses more than 10 petabytes of data. We have about 120 digital products. The numbers are growing. We have about 2,000 common data model in our silver layer and have approximately 12,000 data assets. We run a little more than 21,000 pipeline per day. And over a period of time, we saw about 50% productivity improvement by using this unified platform. This is a high-level representation of the Data Foundation platform and the services it has. As you can see in the diagram, we have a lot of services built in and around Data Foundation. Our architecture includes ingesting data from variety of internal and external sources and moving the data through landing, bronze, and silver layer. Gold is a KPI layer that the application teams build on top of silver, but is outside the scope of the Data Foundation. We have built a lot of services in Data Foundation, like data onboarding service, testing service, logging, audit monitoring, data quality, and DevOps services. We have some of these services are core to the framework, and some services are optional that the application team can choose while they execute their pipelines. We have some data modeling related services as well. Like we have a data serve interface, which is a GraphQL based interface that the application team uses for application data modeling. This completely hides the complexity of the underlying bronze and silver layers. We have data modeling service, which actually enables the data modelers to create the common data model in silver layer by automating the logical to physical data model process. With low-code interface, wizard-driven data onboarding, we empower our end users, technical and business users alike. All these services, these modularized and scalable services, helped us to maintain the agility without compromising the governance. And this entire platform is centrally governed, even if the teams are distributed and operates in a federated model. One of the core design principles of the Enterprise Data Foundation was to hide complexity from the end users and give them a self-service options. So we have built a portal on top of it. It's an in-house portal that we have built. That portal hides the complexity of this entire platform. The end users logs into the portal, they configure their data assets, they configure their pipelines, pipeline frequencies, data quality rules and everything. And that portal takes care of the rest of the stuff. Now this is a quick roadmap of our journey. We have started our journey in 2022 when we have released the very first version of the ingestion framework. That time it was a purely backend driven framework, no GUI on top of it. Slowly we have started releasing all the core services of the foundation like DQ service, DevOps service, audit logging, monitoring services, etc. Around Q3 of 2022, we have released a feature in Enterprise Data Foundation where user can get access to the bronze and silver layer data using conditional RBAC that the Azure provides. That gives some kind of a control over the data, who has access to the data and who cannot access the data. Those kind of control we have used using conditional RBAC. Around the end of 2022, we have released the first version of the portal that I have talked about. In 2023, we have started introducing streaming use cases with the framework, and we have to scale up the infrastructure of the entire platform to handle the massive data, the load that is coming from the global sectors. We have also released another framework in 2023, is a dependency framework to handle complex pipeline dependencies between bronze, silver, and gold. In 2024, we have integrated our platform with Unity Catalog, which is our main data governance and data security platform. We have also started using various partition pruning mechanism in 2024 and also started using serverless DB-SQL. Around the end of 2024, we have started exploring UC Open API, which is our topic today. We'll cover it up in later slides. So since last year's summit, our main focus on to deepening integration with Unity Catalog, we have moved more and more data under UC, and we have started retiring the legacy Hive Metastore. These are very high-level consumption patterns we have in PepsiCo and where UC Open API fits in. As we have started decommissioning Hive Metastore, so our ingestion framework has to ensure a dual mode compatibility between the Hive Metastore and the Unity Catalog Metastore to make sure the business continuity during this transition phase. As you can see in the diagram, on the very right is the Enterprise Data Foundation data lakes. We have multiple data lakes. On top of it, both the Metastore seats, the Hive Metastore and the Unity Catalog Metastore, and both the Metastores are in sync, as I've said. On the left-hand side, there are three different kind of consumers we have. At the bottom, we have the UC-based consumer. That means the Enterprise Data Foundation consumers whose workspace is already UC enabled. So they can query the UC Metastore in two different ways. The preferred way is UC plus HMS cluster shared mode, so that they can directly query the Unity Catalog Metastore. For some reason, if they prefer to run a custom mode HMS cluster, they can use a SQL warehouse through JDBC, and through that SQL warehouse, they can still connect to the Unity Catalog Metastore for querying purpose. At the top is our non-UC consumers. That means their workspaces are not UC enabled yet. They can still retrieve the data from Hive Metastore through the conditional RBAC that I have just spoke. But if they want to query the UC Unity Catalog Metastore, they can still come to, there is a global SQL warehouse the Enterprise Data Foundation host. Through that SQL warehouse, through JDBC connection, they can come and query the UC Metastore. The third kind of customer that we have is our non-Databricks customer. So there are some projects and there are some organization in PepsiCo, they prefer to run their loads on AKS. They do not use Databricks as a compute. These are the customers where the UC Open API fits in the best. I will cover these things in details, but for the time being, let me hand it over to Deepankar to walk you through the UC Open APIs.
Thank you. So before Sudipto dives deep into how PepsiCo has adopted Unity Catalog Open APIs in their enterprise data foundation platform, let me help you understand what is UC Open API and then how it works. Right now, how many of you are using UC Open API? Okay. Yeah, of course. So before we understand the real value of UC Open API or Unity Catalog Open API, let's understand the challenges that the enterprises face today. The challenges with catalog interoperability. So enterprises use different types of data platform. They have data lake, they also have data warehouses, and they also have databases, and they operate all of these in silos, and they have catalogs for each one of these types of data stores. So when your data platforms are siloed and data and AI assets are siloed, you always need to do something extra to integrate them together, be it a ETL pipeline, be it some kind of custom code. And again, managing those things are not easy, as we all know. Secondly, when your data and AI assets are siloed, each or every of these platforms need governance and security on top of those platforms. So now that means automatically your data governance, your discovery is fragmented. And that just not increases administrative burden, but also it increases the inefficiencies in the whole system. So a simple example could be who has done what, if the admin wants to know. Just a simple audit report. That could take quite a lot of effort to get across all these disparate data sources. And finally, the redundancy in compute and storage increases the overall cost. So how can we address these challenges? What does a simple solution looks like? What we should be looking for from a platform? So first thing we are thinking about this platform is unified governance. Irrespective of the type of platform you are keeping your data in, I should be able to, or maybe the type of formats, because enterprises tend to have different types of data formats, and they also have different data assets, such as tables, views, but also in today's world, AI assets such as ML models. So if there is a platform which could provide that unified governance layer to access all of this data, even if they are scattered across or siloed across these sources or data stores, that could be a good solution. But then how do I access that data? Am I only kind of sandbox into that platform where this unified governance is, or can I access and use my choice of compute to access this data? So that's open connectivity. And finally, in today's world, is it harnessing the power of AI and ML? Does it have the built-in intelligence? So since we are talking about governance, so think of having a platform which can provide auto classification of your data or auto tagging, or as your data is getting ingested into your platform, it is automatically optimizing your data. So we talked about challenges, we talked about how a simple solution could look like, and we created Unity Catalog, the first unified catalog for both data and AI assets. Unity Catalog supports multiple format, Delta Lake, Parquet, Iceberg, a unified platform. It supports multimodalities. That means we talked about tables, we talked about views, it also supports AI models, files, and so on and so forth. Also, based on your choice of compute, you can access the data governed within the Unity Catalog using any external engine. So Unity Catalog really unifies the lakehouse. Using UC Open API, REST API, or using the Iceberg REST API, you can access data governed by Unity catalog. Not only that, you can federate your other catalogs into Unity catalog. So this is the unified governance piece I was talking about earlier. So let's say you have data in HMS, Hive Metastore, in Glue or in Snowflake Horizon or Iceberg REST catalog. Wherever your data is, you could federate those into Unity catalog. So that gives you that unified governance layer. The second piece we talked about was the open connectivity. So with the UC Open API and the Iceberg REST API, Unity catalog gives you that ability to access your data from any external or any engine of your choice. And not only that, with delta sharing, you can collaborate across platform in a secured fashion by sharing your data with delta sharing client. And finally, Unity catalog on Databricks is already built on the data intelligence platform of Databricks. So it's already using all those built-in intelligence and features available to the Databricks platform. Now, I will talk, because this talk is about UC OpenAPI, so I'm not going deep into other aspects of UC. So I'm trying to focus on how these different clients, Delta clients or Iceberg clients such as Trino or DuckDB for Delta clients or even open source Spark can be used by using these Iceberg REST API or Unity REST API to access the data that is governed in Unity catalog. So one of the things we need to understand is a feature called credential vending that is provided by Unity. So let's understand what is credential vending and how it works. But before we dive deep into what is credential vending, let's look at a query execution without credential vending and how it works in a lakehouse. So think of a catalog service, let's say, for example, let's take Hive Metastore, and the user who is an authenticated user in the system is trying to do a simple query or run a simple query which is select star from a table. The table is managed within the catalog, but on the rightmost side, if you see, there are two things that the admin has to do for this to work. One is at the top, permission to the metadata, and the bottom, permission to the storage layer. So we all have done this. We have used Hive Metastore. We know that we have to have these permissions. So that means now you are creating two different places, manage access management, and that could just go wrong at any point in time, could go out of sync, or there could be some misconfiguration, and there could be potential security problem. But in this case, let's walk through, and because then we'll appreciate with credential vending how it is different and how it is much better. So the user files a query. There is a query engine which can access data from, in this case, Hive Metastore. And so the first thing it does, it authorizes if the user has select on that table, because user is doing a simple select on the table. We already granted select to that user, but that was the first part of the process where we granted access to the metadata. We also had to make sure that the grant is given to the user to the storage via instance profile or managed identities, depending on which cloud platform you are using. So when the authorization is successful to that table, then the user, the Hive Metastore generates the storage path where the data is actually stored. And then the query engine uses that location to fetch the data, but this time it uses the second part of the access policy, which is to access the storage. And if it is successful, then it goes back. So you see, there are multiple moving pieces here, and it could go wrong anywhere in between. Versus this picture looks much more simpler with Unity catalog. Unity catalog Metastore is where you will define this access policy only once. So how it is different, if I go back to the previous one, look at point number 3 here versus here. So what Unity catalog is doing here, it's generating giving not only the storage path, but also generating a temporary short-lived downscope token based on the access policy that was defined by the admin on the right-hand side. So this is credential vending, and this is how the external engine can securely access data which is managed within the Unity catalog. So let's walk this through. quickly. Again, the user is an authenticated user in the system wherever he's running the query from. The query engine can access Unity catalog. So the second step is, of course, the authorization to the table. We already granted access permission or granted select on this table to the user. So that's also good. Authorization passes successfully, and then this is where the credential vending comes into picture, where the Unity catalog now generates the temporary credential along with the storage part. So it's like having the address as well as the key. So I give both, and then I tell the query engine, okay, go and fetch the data from this, and by the way, this is your key. And then Unity catalog kind of sideline itself from that whole process because it doesn't need to do anything else. So at that point, access is done through the query engine kind of access that data through using that vended credential and sends the result back to the user. So today, Unity catalog is the most open, powerful, and interoperable catalog for your data and AI assets. So with that, now I will hand it back to Sudipta, who will talk about how they have used UC OpenAPI in EDF.
Thank you, Dipankar. So why we chosen UC OpenAPI? One of the reasons I already told that we have some Databricks, we have some consumer, EDF consumer, who are not using Databricks, they are using AKS as a compute. For them, UC OpenAPI is a best suited technology to query the UC catalog. There are a couple of other drivers like cost and performance optimization. Now, as we have two different computes available, one is Databricks, one is AKS, the consumers can pick and choose any one of them based on their performance and cost requirement for their given project. Another key driver was fault tolerance and scalability. As we have two computes available right now, now I can programmatically switch the computes between Databricks and AKS in some kind of erroneous scenarios. That also gives fault tolerance as well as scalability both to the application. Extensibility and centralized monitoring is another driver. Extensibility is a little tricky. We've seen over a period of time that some of the Databricks utilities need some kind of customization based on very specific project needs. Say for example, dbutil class. dbutil class has a lot of good utilities that you cannot change as if you are there in the Databricks as a compute. But if you are using AKS, writing your own custom code, then you can customize those utilities as per your project need. In fact, we have built a library with all those customized functions and utilities that any application project team can include, and then they can extend those further. Centralized monitoring, like in the previous world, we have Data Factory as a orchestration framework, Databricks log, Data Factory logs, and in between any system logs, every logs was scattered. Right? Now, if you use AKS and OpenAPI on top of it, you can centralize all those logs. I'll share you in the next slides. How you can centralize all the logs together to create a complete end-to-end infrastructure plus application monitoring dashboards. Another key driver, a very important driver, is interoperability and integration with third-party applications. Now, if you are using Databricks, most probably you are using PySpark or Scala as your programming language to write your pipelines or data manipulation codes. But if you are using AKS and you are writing your own code, so generally we use API to start the AKS nodes and cluster. Those APIs can be written in any language of your choice. We have used Fast API as a Python-based framework, but you can write that API in C# or Java or any language, and then API can be called from Data Factory, Airflow, or any orchestration engine. Even if you have a say Java application or a React application wants to connect to Intercatalog Metastore, you can use the same API and the process to connect to the Intercatalog Metastore and get the data. So this gives a greater interoperability to the applications for if there is a heterogeneous platform, if they want to talk to each other with Intercatalog, that gives that opportunity as well. And what is the observation after all our testing? So on the left hand side, if you see some of the variables that we have used, so we have used all partition tables from 4 gigabyte to 10 gigabytes in size. We have used DS4 V2 as a node in both Databricks and AKS. On the AKS side, we have used 1 to 4 node autoscaling cluster and 1 node without autoscaling clusters, just to handle, just measure what the performances are. We have used read, upsert, append, all these kind of modes. And when we wrote the queries and when we executed the queries, we have used few queries with no transformation at all, and some of the queries has high to moderate transformation. And we ran both of these in parallel, both in UC and UC OpenAPI and AKS and Databricks, both the sides. And what is our observation in terms of performance? Performance is pretty much similar between these two computes. If you run the same load in both Databricks and AKS, the performance is kind of similar. In terms of cost, it's basically twofold. The VM cost in this particular case, it is a standard DS4 V2 VM. The VM cost is kind of same between AKS and Databricks, but the main differentiator is the DBU cost. As you know, like Databricks, if you are running a job in Databricks, they have, there is a DBU cost associated with that, but that is not applicable for AKS. So that is the main, key differentiator between these two environments. Now let me quickly walk you through the high-level architecture, how we have implemented OpenAPI, and how it is giving you, interoperability and centralized logging and stuff like that. So the user here is basically a developer. So a developer generally writes two types of code. One is the API code that I have spoken. This API code could be written in any language of your choice, and they can also write raw open Spark code to retrieve the data from UC catalog. Both of these codes, the developer checks into Git and they authenticate to Git with Okta authentication, and they check in the code there. Or once the code is checked in and the pull request is made, after the pull request is approved, the DevOps pipeline runs and it creates a Docker image, both for the API and for the Spark notebook. Those Docker images are pushed to the Azure Container Registry, and the Git authenticates to Azure Container Registry using managed service identity. So now in the ACR, you have both of your images are ready. One is the API image, one is the job image, and the API image needs to be running all the time in one of your AKS cluster, and waiting for some kind of an input. So the developer next can write their orchestration pipeline. The orchestration pipeline can be written in Data Factory, Airflow, or even any kind of third-party application wants to connect to Unity Catalog. So in our case, we have used Data Factory. In the Data Factory, we have used an web activity to call the API endpoint. So once the API endpoint is called, it basically pulls the Docker image which has the Spark notebook, and the Python app is mentioned in the picture, and that image is basically starts running into AKS cluster in one or multiple nodes based on the cluster configuration or the load in the system. These jobs eventually talks to the Unity catalog. We used service principal and pair token based authentication to authenticate to the Unity catalog, and Unity catalog is eventually connected to the storage with the external location. And that's how the data gets retrieved by the end user. We have used log analytics, as I was saying, that centralized logging and monitoring. We have used log analytics as centralized log analytics, where you have kept the AKS infrastructure logs. We have kept the Python app, the Spark log, raw Spark log, and the fast API logs. So now you have one centralized location where you have all your logs available. So you can build a Grafana dashboard on top of it to see end-to-end infrastructure versus your application logging in one single place. Some of our lessons learned. First one is UC Open API still doesn't work with dynamic views. So if you have written a dynamic view on UC to handle your granular level access control, you cannot still call that with UC Open API. Another limitation that we saw is save as table function, the data frame save as table function. If you are using save as table function with UC Open API, you have to pass the delta path as a parameter to that function. Without that parameter, the save as table doesn't work. Now, it comes with a little challenge because UC itself uses external location as a path, and you are also sending a path to the save as table function. So you have to a little bit careful. You have to manage the paths a little carefully, otherwise there could be a conflict. So we have reported this to Databricks, and Databricks is working on it. So this will be fixed in one of their future releases. AKS infrastructure, that's another challenge. It's not a challenge for everyone, but because the managing the entire AKS infrastructure, the networking behind it, and all the clusters, pods, and everything could become a little bit of challenge for some of the teams based on their technical skills and stuff like that. So these are the main 3 challenges we have seen so far. Otherwise, it's working perfectly. This is a very high level, code flow, how the codes are organized and how it flows from end to end. So the user is the end user of the API that basically starts the API, calls the API endpoint, which in turn instantiate the Spark instantiate the classes that starts the Spark job. That eventually calls the pod selector class, which is basically responsible to read all the cluster and the Spark configurations that we have and gives the object back to the Spark job submit class, which eventually creates the job into the Kubernetes cluster. These are how the configs looks like. On the left hand side, you can see there is a cluster config YAML, which has small, medium, large size cluster configurations. You can play around with this number. You can tell like what is the minimum node, maximum node you need, what is the memory sizes, and all those stuffs. And the right side is the Spark configuration YAML, which we have used to keep all our Spark configuration that is required at the runtime. These are the configuration file I was showing into the previous picture, that the pod selector class uses this configuration eventually to create the Docker image and the clusters and the nodes accordingly. These are high-level code snippet on how the UC Open API is configured and the Spark notebook, the Open Spark notebook. As you can see in the picture in the bottom, there is a yellow star which shows how we have configured the UC Open API. This is the configuration file of the API application itself, where we have kept the UC Open API endpoint. Once you execute your Open Spark notebook, which is a very give a very crude example here, just select start from a table and put the output in a data frame. It could be as simple as that, or it could be much more complex. When this Spark job executes, it uses this Open API endpoint to communicate to the UC metastore, authenticate there, and bring the data back. These are some useful links that once this is uploaded into the Databricks website, you can use these links to know more about UC Open API and UC as a whole. So yep, this is to summarize all these things. So UC Open API over AKS gave us enough flexibility in terms of interoperability, scalability, fault tolerance, and it also helped us to decouple compute from governance. We have actually moved one step closer to a truly fault tolerance, open, and secure data platform while enabling faster and cost-effective data operation. Thank you, and we are open to hear any question you may have.